So
maybe
we don't
that's,
have stuff in the back.
that's a reasonable
But
one.
we do
I'm
have
sure you'll see something like that.
so we simply add them together.
Can everybody recognize that that is quadratic?
No. So we should write this.
So, can you recognize that the A is a 2, the B is a -3, and the C is 1?
Okay, well, you're trying to find the sine of something better, so you set up your second equation, which is I don't know what I have over there.
I know.
Or whatever it is that you're trying to solve for. That's it states. Find the value of the sine of something like this, so this.
It helps to know the quadratic equation. B is a -3. That would make that be a 3. There will be two answers. One's positive, one's negative. B squared would be none. A is 2, C is 1. The entire quantity is divided by 2A. Oops. Thinking ahead there. So that's 3 plus or minus the square root of 9 take away 8 divided by 4. So 3 plus or minus the square root of 1 divided by 4. So we have two answers, 3 plus 1 divided by 4. Or 3 take away 1 divided by 4. Doing one at a time. I think everybody saw that that's 1. X equals the inverse cosine of 1. When you do that, you will get 0 degrees. Now, when you find the other cosine, you always take the opposite of it. So the other answer would be a -0. That really tells you that there's only one place in the unit circle where the cosine is 1. So this is just a single answer, 0 degrees. Whew. Finally, something that looks easy. Maybe. At least relative to some of the others. Do the same thing here. So cosine of x equals positive 1/2. Take the inverse cosine. 1/2. I think I get 60. And then the other answer is -60. So for cosines, if you get one answer here, the other answer is down here. So if you get a theta, the other answer is always a negative theta.
And when we have 360 to make it non-negative.
And then you realize the directions, and they say that -60 is not allowed. So we go around the circle one more time. And we find 300. And then finally, to be clear,
did you know you were solving for cosine of x? There's also, oh, never mind.
Were you able to answer that? Okay. So, at the very beginning, it had cosines. I know I was trying to find the letter x, and so I took the inverse cosine at the end, because what this is telling me is that the cosine of x is what that quadratic equation
Could
turns out.
sine equal that though?
Yeah, could be a sine also.
What happens when there's a sine and a cosine in the equation?
Well, then we have to find a clever way to make one of them go away. And it would make more sense to try and do that as an example